find the derivative of a power function. So a power function is when you have variable raised to a power. And there's a pattern for these things. So look at the pattern and use inductive reasoning to determine what is the rule that's being applied here when we take the derivative of a power function. Notice that in each of these original functions, we have a power that also appears out front of the derivative. So the original function is in the parentheses. You have this apostrophe on it, which means to take the derivative of the original function. What you get on the other side is the derivative function. Okay, so this one is f of x, and you're taking a derivative of it. And over here, what you have is called f prime of x. So each time, what I'm saying is the power comes out front, 4 comes down and goes in front. And then also notice that the power, like what's that power if there's not one written? That's a 1. And notice how the new power is 1 less than the old power. Okay, so just through inductive reasoning of what's happening here, they are taking x to a power, doing the derivative of it, and coming up with a new function which is nx to the n minus 1. That's the general rule for differentiating, it's called, a power function. This is called the power rule for differentiation. So let's do an example. X to the 70, and you want to do the derivative of it. It's going to become 70x to the 70 minus 1. So it's going to be 70x to the 69. If you have something like, let's say, x to the 1/2, and you want to do the derivative of that, power rule still applies. What we want to do is bring the power, whatever it is, down in front. 1/2 x to the new power being 1/2 minus 1. You may have to get a common denominator for that exponent there. It's 1/2 x to the negative 1/2. Now in calculus, you don't have to simplify usually unless it's otherwise specified. So you could just leave it like that. If you did simplify it, you'd realize that a negative power follows the rule of x to the negative power can become 1 over x to the positive of that same power. So this would therefore become 1/2 times 1 over x to the positive 1/2. You move him from where he is down below, and you switch the sign. So this would become 1 over 2 square root x. That would be most simplified, but like I said, in calc, it doesn't usually matter. You might find that you have a case where you have, let's say, 5 times a cube root of x squared. What if you had that? Could you use the power rule on that? You could. So if they say take the derivative of this, that's what the d over dx means. Take the derivative. Then we have this rule that if we ever are trying to take a derivative of a constant times a function, k here stands for just a number. F here stands for a function of x. We have this rule that the constants can just come right out of the differentiation. Okay, so what this will become then is going to be k times d over dx of f. Okay, so the constant is like a spectator who gets multiplied back in after you do the derivative. So in that same sense, I can bring the 5 out front and make this 5 times d over dx of the cube root of x squared. And I'll just focus on differentiating this part. Later, I'll multiply the 5 back in. You want to rewrite your expression with a rational exponent. All right, so we have this rule that if you ever have like a nth root of a thing, then that can be rewritten as f to the 1 over n. You know, that's the rule for roots. Okay, so in that same way here, we would now make this 5 times d over dx of x to the 2/3 would be his rational exponent. To break that down just a little more, like in case that was unclear what I did there, I said that I'm raising x squared to a power of 1/3. Okay, the cube root becomes 1/3 power. There's a rule where you have something raised to an exponent where you want to raise that to another exponent where we would multiply the exponents together. And so that's what I basically did here. I figured, okay, we've got 2 over 1 on the inside, 1 over 3 on the outside. We multiply the tops times the tops and the bottoms times the bottoms to finally arrive at x to the 2/3. You want to do the power rule now on x to the 2/3. So what's it going to become? We have to follow the rule that x to the n, his derivative becomes nx to the n minus 1. So following that rule, the 2/3 will now come down in front. And you would just subtract 1 from the 2/3. So we'll have this, and then 5 times 2/3 x to the negative 1/3. We can now have the 5 just come right back in if we want. You could just leave it like that as is if you want, but if you want to simplify a little, we make it 10/3 x to the negative 1/3. Here, the 5 only gets multiplied by the top, not the bottom, because in fraction multiplication, tops get multiplied by tops, bottoms get multiplied by bottoms. So we'd get that.